Chapter 1, Real Numbers, Session 3. Let's start. So let's start with the theorem. Let the p be a prime number. Let the p be a prime number. If p divides a square, then p divides a. Then p divides a, where a is a integer. Right, here it is written that p is a prime number. If it is a non-prime number, then it is also fine. How? Let's see here. See here. Here what is the statement is p divides a square. P divides a square means 16, right, divided by 2. So 2 is a prime number. Okay, 16 divides the 2. Answer is 8. Then it is also divides a. See, this is the 4 square, right? 4 square. So it is also divide 4. So 4 divided by 2 is equals to what? 2. In that way, if p be the prime number, if p divides a square, then p is also divides the a. Another example, for example, 81, right? 81 is nothing but the 9 square, right? If it is divided by 3, what is the answer? So it is nothing but the 27, right? So this 3 also divides 9. So 9 divided by 3 is nothing but the 3. So this statement is like that. If p be the prime number, if p divides a square, then p divides a, where a is a positive integer. A is a positive integer. I said integer. Integer means what? It is not the decimal value. This is wrong, right? It might be a 15. It might be 150, whatever it is, but it is an integer. It might be a minus 150. It might be a minus 5, whatever, but it is an integer, not a decimal, right? Now let's move ahead with the exercise 1.3. In exercise 1.3, the question is, prove that square root of 5 is irrational number. Prove that square root of 5 is irrational number. Let us assume, see here, I'm going to do this sum step by step over here. Later I'm explain this. So first of all, assume that square root of 5 is a rational number, therefore it can be written in the form of a by b, where a and b are the co-prime numbers. What is the co-prime number that we already see in the previous lecture? Now b from the denominator goes into the numerator. So b into square root of 5 is equals to a. Now squaring on both the side. So squaring on both the side. Right? So 5 square is nothing but the 5. B square is b square is equals to a square. Now it is simple. Right? Squaring on both the sides. So 5b square is equals to a square. Therefore a square divides by 5. Then from the theorem 1.3 that we already see, it follows that a is also divisible by 5. Right? How? See, b square is equals to a square by 5. If a square is divisible by 5, then a is also divisible by 5 from the theorem 1.3. Right? So this thing up to here, let us assume that the contrary, because we need to prove that irrational. So contrary is that root 5 is a rational number. Right? That is, we can find out the integers a and b, where b is not equals to 0, such that square root of 5 is equals to a upon b, such that a and b have a common factor other than 1. Common factor other than 1 means what? A and b are the co-prime numbers. Simple, right? Then we can divide the common factor and assume that a and b are the co-prime numbers. So b is equals to that we already see, right? B from the denominator goes into the numerator. Squaring on both the sides, we get 5b square is equals to a square. Therefore a square divides by 5. From theorem 1.3, it is follows that a is also divisible by 5. So the statements you need to remember. Now let's move ahead. We can write a is equals to 5c. How? See, we know that a divided by 5 is equals to some number. Assume that it is c. Answer is c. Right? So a is equals to 5c, right? So a is equals to 5c. Now squaring on both the sides. So 5b square, substituting the value that 5b square is equals to 25c square. How? See, first of all, squaring on both the side. See, first of all, here what you need to do is squaring on both the side, and that is a square is equals to 25 squaring on both the side, and that is a square is equals to 25c square. Now you need to put the value of a. So what is the value of a? The value of a is nothing but the 5 square root of 5b. Now square is equals to 25c square, right? See here once again. See here, a is equals to 5c. Now instead of a, we need to put the value. So what is the value of a? So what is the value of a? See, the value of a is nothing but the b square root of 5. The value of a is nothing but the square root of 5b or b square root of 5, right? So here we have a is equals to 5c. So instead of a, we need to put the square root of 5b is equals to 5c. Now squaring on both the side. Then squaring on both the side, we get 5b square is equals to 25c square. That's 25 and 5 cut, and here it is 5. So b square is equals to 5c square, right? So b square is equals to 5c square. Now here the same. If b square divides the 5, then b is also divisible by 5, right? See here, first of all, a is divisible by 5. Here we prove that b is also divisible by 5, right? Therefore a and b have at least 5 as a common factor, right? Because a is also divisible by 5, b is also divisible by 5. When a is divisible by 5, that number might be 10, for example. B is also divisible by 5, that number might be 15, right? A is 10 and b might be a 15. Both are divisible by 5, right? So these numbers are not the co-prime numbers. They have at least common factor 5, right? And what we assume that they have the common factor only 1, but here it is wrong that they have at least 5 as a common factor. So our assumption is wrong, but this contradicts the fact that a and b are the co-prime numbers, right? Why? Because we already see in the previously that a and b have only 1 as a common factor, but here 5 is a common factor. So this contradicts the fact. Why this contradicts the fact? Because this contradiction has arisen because of our incorrect assumption that square root of 5 is a rational number. So therefore we can say square root of 5 is irrational number. Okay. So in the same manner we need to do this sum, but the method is slightly different. Let us assume that the contrary, that 3 plus 2 square root of 5 is a rational number. That is, we can find out the co-prime numbers a and b where b is not equals to 0, such that 3 plus 2 square root of 5 is equals to a upon b. Now this 3 goes on to the another side, right? Or you can say that 3 goes on to the another side. So a by b minus 3 is equals to 2 square root of 5. Now rearranging this equation, so square root of 5, this 2 from the numerator goes into the denominator. So square root of 5 is equals to a by b minus 3 upon 2. So square root of 5, if you do the simplification over here, so a by b minus 3 divided by 2. Now b is what? LCM. So a minus 3b upon b divided by 2. So denominator and denominator multiplies each other. So therefore what we have to do here is, here it is going to be the 2b. So therefore a minus 3b upon 2b. Since a and b are the integers, we get, since a and b are the integers, if they are the integers, this number is a rational number. If a and b are the integers, this number is going to be the rational number. So root 5 is also the rational number. If this is the rational number, see here, if one side is a rational, another side must be the rational, because if it is equals, so both the side is equals. Here if it is a rational number, then here also the rational number. If this is the rational number, then root 5 is also the rational number. But this contradicts the fact that root 5 is an irrational number, because we already know that root 5 is an irrational number. So this contradiction is arise because of our incorrect assumption that 3 plus 2 square root of 5 is rational. So we conclude that 3 plus 2 root 5 is a irrational number, right? So we have this two method. So the first one is this, that square root of 5. In the square root of 5, what we have to do? In the square root of 5, so first of all, square root of 5 is equals to a divided by b. Then a is equals to square root of 5b. Then squaring on both the side, a square is equals to 5b square. Now what is the value of a? A value of now a is equals to 5c, because if a divides 5, a square divides 5, then a is also divides 5. Now what is the value of a here? That is root 5b. So here root 5b is equals to 5c. Now squaring on both the side, so 5b square is equals to 25c square, right? Up to here you know. Now 5b square is equals 5b square is equals 25c square. Therefore b square is equals to 5c square. If b square divides 5, then b is also divides 5, right? A is also divides 5. So they have at least common factor 5. Therefore, it contradicts the fact that root 5 is a rational number, and thus contradiction has arisen because of our incorrect assumption. Therefore, we conclude that root 5 is an irrational number. And here what we have to do, simple, make the root 5 alone, and another terms on the another side of equals to, that means on the right hand side, right? If here right hand side is a rational number, therefore root 5 must be the rational number, but this contradicts the fact that root 5 is an irrational number. So this contradiction is arise because of our incorrect assumption, and that is 3 plus 2 root 5 is a rational number. So we conclude that 3 plus 2 root 5 is a irrational number, right? Now question number 3, prove that following are the irrational number. So here 1 upon root 2. Let us assume that contrary that 1 upon root 2 is a rational number. In each and every sum, this kind of a sum, you need to do that it is a irrational number. First of all, we need to put the irrational. So we have to assume that root 2, the number is a rational number. Therefore, we can find out the two co-prime numbers a and b, where b is not equals to 0, such that 1 upon root 2 is equals to a by b. So root 2 is equals to b upon a. Why? Because here what we have to do, root 2, see 1 upon square root of 2 is equals to a upon b. Now b goes on to the numerator, a comes on to the denominator, right? So b divides a is equals to root 2 onto the numerator, and 1 comes into the denominator. So b by a is equals to square root of 2. So b by a is equals to square root of 2. So b by a is a rational number, as a and b are the integers. Therefore root 2 is a rational number, which contradicts to the fact that root 2 is an irrational number. Hence our assumption is a false, and 1 upon root 2 is a irrational number. So this sum is very easy, right? We do not need to do the long method which we see in the very first sum, right? Here we need to do just that root 2 goes into the numerator. So root 2 is equals to the b by a. Here b by a is a rational number. Why? Because a and b are the integers. Therefore b by a is a rational number. Now therefore square root of 2 is a rational, which contradicts to the fact that root 2 is an irrational number. Hence our assumption is false, and 1 upon root 2 is a irrational number. Now in the same 7 square root of 5, let us assume to the contrary that 7 root 5 is a rational number. We can find out the two co-prime numbers a and b, where b not equals to 0, such that 7 root 5 is equals to a by b. So root 5 is equals to a by 7b. A by 7b is a rational. A by 7b is a rational as a and b are the integers. So therefore root 5 is a rational, which contradicts to the fact that root 5 is irrational. Hence our assumption is false and 7 root 5 is an irrational number. Here we also do the same thing that we see in the previous sum, that 7 square root of 5 is equals to a by b. 7 from the numerator goes into the denominator, therefore root 5 is equals to a by 7b, right? But this side is a rational number, so this side must be the rational number, but this contradicts the fact that root 5 is an irrational number. This contradiction has been arised because of our false assumption, and hence 7 root 5 is an irrational number, right? Now the last sum for the today, and that is 6 plus square root of 2. So let us assume to the contrary that 6 plus square root of 2 is a rational number. Let us assume that contrary that 6 plus root 2 is a rational number. Therefore we can find out the two numbers a and b where b is not equals to 0 such that 6 plus root 2 is equals to a by b. Now 6 goes on to the another side, it becomes minus, so root 2 is equals to a by b minus 6. Here a and b are the integers, therefore a by b minus 6 is a rational number. Hence root 2 should be rational. This contradicts the fact that root 2 is a irrational number. Hence our assumption is false and 6 plus square root of 2 is an irrational number. So the sums are very easy, and 90%, 95% one sum from this exercise 1.3 definitely there in the exam, right? From the 1.3 one sum is definitely there in the exam. So I hope you prepare this sum very thoroughly, because this is very important as far as your examination is considered, right? So I hope you understood these sums, right? Easy sums. So meet in the next lecture. Till then, bye bye, see you, stay home, stay safe.